let's start talking about reactions now. And we're going to start with alkanes and alkenes. Alkanes and alkenes. Alkanes, as you know, are identified by all single bonds between the carbons. Alkenes have at least one carbon-carbon double bond. You know that. Alkanes, alkenes. How are they different in terms of their reactivity? Well, let's think about this. That line, actually any line, represents two shared electrons. Single bond. Two shared electrons, two more shared electrons. The bonds are shared electrons. Electrons are what are involved in chemical reactions. So that may help you think through why it is that alkenes are very reactive. Alkenes are reactive, and alkanes are unreactive. Reactive, unreactive, here's why. Double bond, no double bond. That tells you that when an alkene reacts, it will be the double bond that's doing the reacting. The alkene, the double bond reacts. No double bond, it cannot do those same reactions. Now, I will point this out though. Alkanes can undergo combustion. So they can do combustion. Alkenes can also do combustion. All organic compounds are combustible. We will be focusing on what they can do in addition to that. Combustion is burn. So alkanes can be combusted, alkenes can be combusted. What we'll be focusing on right now, though, is what can alkenes do in addition to combustion. Combustion is burning. And that is a separate topic. Okay, what will alkenes do? Let's keep it very, very general to start. We'll do it like this. I'll say here's a really general alkene, just like that, right? Double bond, that makes it an alkene. Here's a very general reaction of an alkene. Suppose I react it with XY. XY is just some really general, generic compound. Here's how that reaction will look. Every single time, here's what will happen. The double bond will turn into a single bond. The things that were attached are still attached, but look, since we got rid of the double bond, this carbon needs one more bond. This carbon also needs one more bond. Each carbon used to have 4 bonds, 1, 2, 3, 4, but since we got rid of that second bond, they need another bond, a 4th bond. It's going to look like this. One of the carbons gets the X, the other carbon gets the Y. And this is called an addition reaction. You're adding something to the double bond, addition. What are specific examples of that? I'll show you right now, and the two that we will be looking at and emphasizing are the 2 addition reactions that alkenes do in your body. There are other reactions that alkenes can do in the laboratory, but we will do the ones that happen in your body, and they are these 2. Number 1, an alkene can react with this compound. And I'm going to first write it in a way so that it looks like we did up here. You'll be able to see, okay, what'll happen. Just like always, the double bond will turn into a single bond. This carbon needs one more bond, that'll be H. This carbon needs one more bond, and that will be the other H. Double bond turned into single bond, we added H and H. Usually, that would be written this way. Usually you would not write it like H-H, you would write it as H2. H2, hydrogen. And in fact, this reaction is called hydrogenation. It's pronounced hydrogenation. If you want, you can think of it as hydrogenation. You're adding hydrogen. The word is right there, hydrogen. You're adding hydrogen. The other example of addition that comes up, it's happening in your body right now as you're listening and reading to this, is this. Adding HOH. And you might guess right away what that really is, H2O. Usually it would be written that way, H2O. But I'm writing it this way right now so you can kind of predict what will happen. The double bond will turn into a single bond, as always. What will one carbon get and what will the other carbon get? One carbon will get H, one carbon will get OH. One carbon gets H, one carbon gets OH. This is not hydrogenation. We didn't add hydrogen, we added water. Think of what it means to add water. I suppose you could say that's wateration, but we will call it with a name that should also make quite a bit of sense, hydration. When you need to hydrate yourself, you add water, drink water. Hydrating an alkene means adding water, hydration. Both of these are types of addition. We said that was the general name. These are addition reactions. Addition, these are just the specific names. If what you're adding is hydrogen, we will call it hydrogenation. If what you're adding is water, we'll call it hydration. And the last thing that I would like to add before we go to some examples is this. Usually, organic reactions require a catalyst. You know about catalysts. A catalyst is something that will speed up the rate of the reaction. It's not a reactant and it's not a product. It's something that doesn't change in the reaction. It does not get used up, does not show up in the products. So, do you think this reaction needs a catalyst, requires a catalyst? Yes, it does. Most organic reactions do. Does this one require a catalyst? Yes, it does. Most reactions, organic reactions, do. I just mentioned a moment ago that both of these reactions happen in your body all the time. The catalyst in your body are enzymes. We'll talk about those later on. If we do these same exact reactions in the lab, we use a lab catalyst. The lab catalyst is usually, for this reaction, usually a metal, like nickel. Or it might be platinum. Or it might be palladium. Either way, the way you know that it's a catalyst is it's written above the arrow like this. That tells you that's just a catalyst. It's necessary for the reaction to happen with any reasonable speed, but it's not a reactant, it's not a product. It's kind of like a helper to make the reaction happen. So if you see something written above the arrow, that tells you, oh, that's a catalyst. What is the catalyst here? H+. What do you think of when you see H+? Acid. Right. Acid. You need H+. You add a little bit of acid to make this reaction happen. So sometimes we'll say acid catalyzed hydration. You don't need to worry about the catalyst part. We focus on what is the reactant and what are the products. In the next video, we'll see some specific examples of both of these reaction types.